perguntas devem ser colocadas no chat e serão respondidas durante o debate ao final do evento. Peço, por gentileza, que silencie seus microfones, pois ouviremos agora o presidente da Abnt, Sr. Mário William Esper.
Bom dia a todos. Bom dia às autoridades aqui presentes, o secretário de Estado do Meio Ambiente, André França, doutora Lília Ferreira, secretária adjunta do Meio do Estado, Secretaria de Meio Ambiente do Mato Grosso, secretário de Estado de Meio Ambiente do Rio Grande do Sul, demais autoridades aqui presentes. É com grande satisfação que realizamos este evento, que certamente proporcionará relevante intercâmbio de informações a respeito da classificação de resíduos sólidos perigosos, um desafio para o mundo, em especial para nós brasileiros. Temos visto que o cenário mundial é cada vez mais impactado por mudanças climáticas e seus efeitos. Por isso, a Abnt, Associação Brasileira de Normas Técnicas, vem priorizando a revisão e elaboração de normas relacionadas a temas sensíveis sobre meio ambiente e sustentabilidade. Um exemplo é a elaboração de práticas recomendadas de diretrizes e critérios para a geração de indicadores de ESG, meio ambiente, social e governança. Há também normalização de carbono neutro, biodiversidade, combustíveis renováveis, entre outros temas de preocupação global. Alinhada a este cenário, a Abnt criou a Comissão de Estudo Especial de Gestão de Resíduos e Logística Reversa, a CE 246. Quero aqui já agradecer o nosso colega, o Luiz Carlos dos Atos, que tem coordenado brilhantemente esta comissão, com vistas a agilizar a modernização das normas referentes a esses assuntos, considerando a nova ordem mundial, que é a economia circular. Esse conceito traz uma dinâmica totalmente sustentável, na qual o resíduo de um setor se torna matéria-prima de outro setor. Ressalta-se que a Abnt, como Fórum de Normalização do Brasil e único representante do país nos fóruns internacionais de normalização, tem sido protagonista na participação dos comitês, principalmente da ISO. O caso específico de resíduos está sendo revisado no Brasil a norma NBR 10.004, que trata da classificação quanto à periculosidade dos resíduos. A Comissão de Estudos tem sido desafiada desde que iniciou suas atividades, há cerca de um ano, e não mede esforços para buscar o que existe de mais avançado sobre o tema, em sintonia com o estado da arte da normalização internacional. O encontro de hoje é um exemplo desse empenho para que a revisão da norma 10.004, que deverá se estender até o final deste ano, 2022, contemple uma visão contemporânea do tema, atendendo à legislação brasileira em linha com as convenções de Estocolmo e da Basileia. Por isso, vamos conhecer e trocar experiências sobre o que está em desenvolvimento na Europa e no mundo em relação à gestão de resíduos perigosos. Agora que o Brasil foi oficialmente convidado a fazer parte da Organização para a Cooperação no Desenvolvimento Econômico, a OCDE, a iniciativa se torna muito mais importante e relevante. Reitero que o objetivo é oferecer norma de qualidade em alinhada às melhores práticas mundiais, como tudo que fazemos aqui na Abnt. Organização essa que, com mais de 81 anos de existência, ainda se reinventa. São exemplos dessa renovação As recentes práticas recomendadas, que são documentos que passaram a ser publicados pela ABNT em 2020, em resposta à urgência da epidemia da Covid-19 e destacam pela eficiência e agilidade na sua elaboração. Vivemos tempos de transformações na normalização e destaco que, atualmente, 3 grandes motivos colocam em evidência essa atividade no Brasil. Primeira, a Lei da Liberdade Econômica, que afeta diretamente a normalização, pois diz a lei, se não existir norma, a norma estiver desatualizada, considera desatualização mais de 3 anos, ou se não existir normas, a ABNT adota-se normas internacionais e, mais além, as normas internacionais elaborada pela ISO, como Fórum Único de Normalização no Mundo para esse assunto. O segundo motivo é a lei sancionada em 1º de abril de 2021, que é a Lei 14.133, de licitações e contratos administrativos, que estabelece maior isonomia competitiva aos fornecedores de produtos e serviços para a administração pública, minimizando a concorrência desleal. Além de oferecer margem preferencial para bens e produtos em licitações, tanto nacionais como internacionais, que atendam às normas técnicas. A lei determina que o fornecedor apresente prova de qualidade em conformidade com as normas técnicas. E o terceiro motivo é o novo marco regulatório, que o Inmetro lançará agora no dia 25 deste mês, com a presença do presidente da República. Entre outros dispositivos, indicará que, para ser elaborado um documento normativo, seja ele compulsório do governo ou do âmbito da ABNT, tem que ser elaborado antes uma análise de risco. Se essa análise apontar risco alto, cabe regulamento técnico emitido pelo governo, que é obrigatório. Caso avalie médio e baixo, cabe à ABNT elaborar essa norma. Portanto, a norma ABNT é uma autorregulamentação da sociedade. É uma norma que tem o respaldo porque ela foi elaborada com a participação da sociedade de forma democrática. Aproveito para dar boas-vindas ao nosso convidado, Dr. R. Van Berg, especialista em empresa Geoport Europa, e que todos que nos acompanham neste webinar. Eu agradeço e, de imediato, nós estamos aí com o problema de tempo do nosso secretário. Eu quero passar a palavra para ele e agradeço muito, André, muito obrigado pela sua participação, pelo prestígio que você está nos dando neste evento. E quero aproveitar de público, em nome da ABNT, para parabenizá-lo pelo excelente trabalho que tem feito no Ministério do Meio Ambiente, principalmente no tocante ao tema que hoje nós estamos trabalhando e que a ABNT tem priorizado, que é a questão de resíduos no Brasil. Muito obrigado. Com a palavra, Dr. André França, secretário de Estado.
Neste momento, eu gostaria de registrar a presença do diretor-geral da ABNT, senhor Ricardo Fragoso, e pedir para que aguardem 1 minuto que o senhor André França já está se conectando.
Fechou?
Eu vou falar?
Pode.
O Léo estava preocupado na conexão dele.
Não, o secretário... O senhor André França está com um problema de conexão, mas em 1 minuto ele já está entrando. Por favor, aguardem.
Vanessa, sugiro que você aproveite para apresentar, só para repassar as regras para as pessoas acompanharem depois no inglês a tradução.
Yes.
Também.
Now I have the translation.
Yeah, you have a translation.
Yes, thanks a lot. Thanks a lot. Sorry, but I was able to follow most of the topic you were speaking. Not. I have to apologize. I'm not speaking Portuguese. That's a failure for my education. But I will have to do it in English, unless you are all French speaking. Up to you.
Okay, we are just waiting the Secretary of Environment. He will give a brief speech. Then we have my short presentation, yours, okay?
Thank you.
Thanks.
Shall I present myself? Okay. Yes, you want. You can present. Not a problem.
Yeah, we just a little bit. Let's wait a little bit. That there's a secretary that is linking to give a short speech, and then we start our technical debate.
Yeah, not a problem. It's important to know, don't hesitate to interrupt me and to raise questions during the discussion. It's not a problem at all. And it's sometimes better than waiting at the end of the presentation. So don't hesitate to interrupt me.
Okay. And we have a
Bom,
very...
retomando o nosso início aqui, nossa abertura do nosso evento, já está conectado o nosso secretário de Estado, André França. André, eu tinha acabado de anunciar aqui o início do nosso evento e agradecer demais a BNT, se sente honrado aqui com a sua participação nesse evento, nessa abertura, sabendo que é uma preocupação sua secretaria esse tema. Eu aproveito essa oportunidade, como reitero, parabenizá-lo pelo excelente trabalho que você tem feito à frente da Secretaria, do Ministério do Meio Ambiente, no tocante à preocupação que nos aflige, que é a questão do resíduo. Eu acabei de dizer, André, que é de suma importância. Se o Brasil agora é candidato ao CDE, a integrar o CDE, isso é fundamental para o nosso ingresso nessa importante organização. Uma palavra, por favor, secretário, e muito obrigado mais uma vez.
Muito obrigado, Mário Williams. Inicialmente, pergunto se vocês me escutam bem.
Sim.
Muito obrigado, Mário, pelas palavras. Também agradeço muito a oportunidade, me sinto honrado de estar aqui nesse importante painel, discutindo um tema tão importante. Me recordava há pouco da primeira vez, acho que a primeira vez que a gente começa a trabalhar com gestão ambiental, uma das primeiras coisas que a gente aprende é justamente a classificação de resíduos. Eu estava buscando na memória as minhas primeiras experiências no órgão ambiental lá há 14, 15 anos atrás. Eu me lembro que uma das primeiras coisas que falava, isso aqui é imprescindível, NBR 2004. Daí, quando a gente para pensar agora, já quase 15 anos depois, a gente vê como que é verdade. Ter uma norma objetiva, né, com critérios claros, parâmetros que orientem de forma a não deixar dúvidas, é essencial para que não haja insegurança, seja ela técnica ou jurídica, essencial para que diferentes profissionais possam estar falando da mesma coisa num universo tão rico, complexo e dinâmico como é a gestão dos resíduos sólidos, e essencial para que a gente tenha segurança e previsibilidade, porque de tantas atividades econômicas, né, que geram resíduos diariamente, se a gente não tiver uma norma capaz de orientar com clareza, né, orientar com objetividade, a gente teria muita dificuldade, né? A norma está quase completando a maioridade, né, se não me falha a memória, já é mais de 17 anos. Então, é tempo mais do que adequado para que essa discussão seja feita. Não poderia deixar também, Mário, de deixar aqui uma felicitação e uma congratulação pelo brilhante trabalho que você tem feito à frente da Abnt e todo o time técnico da Abnt, que muito tem feito para a melhoria da normatização, da normalização, enfim, tem as diferenças semânticas, mas para o avanço das normas técnicas no país. Deixo aqui esse registro, esse reconhecimento, por entender que é uma atividade fundamental para que a gente tenha desenvolvimento sustentável. Quando a gente iniciou a gestão aqui no Ministério, a gente fez rapidamente um levantamento dos passivos, o que a gente precisava fazer, e de lá para cá empreendemos esforços nesse sentido. Desde o lançamento do SINIR, que é o Sistema Nacional de Informações sobre a Gestão dos Resíduos Sólidos, que agora, Mário, eu já deixo aqui um teaser, né? Vamos ter a versão 2.0 do SINIR, que é o SINIR+, vai ser lançado neste mês agora de fevereiro, e ele tem as informações georreferenciadas dos resíduos sólidos no Brasil. Então, tem mapas em 3D, fluxos de resíduos, mapas de calor com potencial energético, a localização das unidades de triagem, reciclagem, disposição final, dos lixões, tudo integrado com malha viária, gasoduto, linha de transmissão, imagem de satélite. Ficou um trabalho muito bem feito, foi uma parceria nossa com a Abnt e também com o BID. Em breve, a gente terá o sistema lançado, e se for do interesse da Abnt, a gente faz uma exclusiva também, apresentando o sistema, o SINIR+, para todos aqueles que estão trabalhando com o tema, né? Porque lá tem muitas informações relevantes, para além de você poder enxergar os resíduos no mapa, né, os consórcios, as cooperativas, enfim, está tudo agora georreferenciado e com várias camadas de informação que podem ser alternadas de acordo com a análise que está sendo feita. Inclusive, tem uma funcionalidade que permite acrescentar uma camada que o usuário tenha na máquina dele, que não seja uma daquelas que está ali pré-estabelecidas, e ele consegue, com essa camada, acrescentar outras camadas que sejam do interesse particular. Por exemplo, ele pode ter ali alguma coisa mapeada dos PGRS ou do licenciamento, ele sabe essa camada de informação e consegue também usufruir do sistema. E também algumas novidades, né? Agora a gente passa a ter, finalmente, relatório instantâneo de conformidade de cada um dos 5.570 municípios. Então, raio-x, que é gerado instantaneamente, mostra tudo que tem sobre resíduos em determinado município. Também vários painéis com mapas de financiamento, logística reversa, enfim, uma série de coisas. Não vou falar tudo, senão tem que ver o bolo pelo forno, pela porta, né? Não pode abrir antes da hora, senão o bolo sola. Então, para deixar um pouco também de suspense no ar, a gente deixa aqui já a informação do lançamento, e se for do interesse da Abnt, o Mário me fala depois, a gente faz uma apresentação exclusiva para a Abnt sobre o SINIR+, esse sistema que, segundo o BID nos falou, isso não foi a gente, não tem igual no mundo. Ficou realmente algo muito completo, que a gente vai ter o maior prazer em apresentar para vocês. Mas, de lá para cá, né, 2019 para cá, tivemos avanços importantes na gestão de resíduos. E, no final, vai ficar claro por que eu estou fazendo a lembrança desses marcos que a gente alcançou. Quando a gestão iniciou, tinham 3.257 lixões, Mário. 3.257 áreas irregulares de disposição de resíduos no Brasil. E, de lá para cá, temos a felicidade de ter 645 lixões a menos. Foram 645 lixões encerrados, uma queda de 20% em pouco mais de 2 anos. E não adianta, todos aqui sabem, trabalham com o tema resíduos sólidos, não adianta só encerrar o lixão se não tiver alternativa pela destinação final ambientalmente adequada. Então, uma série de medidas, desde apoio a municípios e consórcio, só aí já vão cerca de 200 milhões em investimento, mas também programas importantes, como o Programa Lixão Zero, o Programa Nacional de Logística Reversa, recém-lançado, os sistemas que foram criados de logística reversa, novos sistemas como eletroeletrônicos, medicamentos vencidos, baterias automotivas, né, e outros que foram aprimorados, como da lata de alumínio para bebidas, que agora tem garantia de compra a preço de mercado, tem entidade gestora, tem novas centrais, né, e no ano passado foi mais um recorde de 31 bilhões de latas recicladas, e outros que estão aí em vias de desenvolvimento. Inclusive, teremos muito em breve, aí nos próximos dias, uma nova ferramenta que vai impulsionar a logística reversa, que é a regulamentação no território nacional do certificado de crédito de reciclagem. Ou seja, além da comercialização do reciclável, a comercialização do crédito dessa reciclagem para as empresas que precisam cumprir as metas de logística reversa. Mais facilidade para as empresas e mais renda para aqueles que trabalham com a reciclagem, uma abordagem de ganha-ganha, né? E poderia falar muitas outras coisas, mas simplificando, eu queria dizer o seguinte: a gente também avançou na recuperação energética, primeiro leilão de resíduos sólidos urbanos, primeiro leilão de energia elétrica a partir de resíduos sólidos urbanos, Plano Nacional de Resíduos Sólidos, MTR, enfim, um monte de coisa. E por que eu estou dizendo tudo isso? Porque tudo isso que a gente fez, Busato, agora que eu vi você, tudo bem? Tudo isso que a gente fez, se a gente não tivesse a classificação de resíduos, a gente teria tido muita dificuldade em fazer, ou teria sido impossível fazer. Você vê, então, a classificação dos resíduos é algo basilar, é algo fundamental, é algo que sustenta as outras evoluções da gestão de resíduos. Porque se eu não sei separar uma coisa da outra, avaliar uma coisa da outra, tudo é lixo. E hoje eu firmo aqui com o Mário um pacto de que, a partir dessa data, 7 de fevereiro de 2022, a gente não fala mais de lixo, a gente fala de matéria-prima fora do lugar, né? Matéria-prima ou energia fora do lugar. E isso só é possível com uma boa norma de classificação de resíduos. E parabenizo aqui todo o esforço, dedicação, empenho que eu tenho acompanhado o NP colocar sobre esse tema importantíssimo. Contem com o Ministério do Meio Ambiente naquilo que precisarem para fazer essa discussão avançar e que tenhamos, né, no momento adequado, em que tiver amadurecida a discussão, uma norma moderna que traga segurança jurídica, segurança técnica, objetividade, que abra os caminhos para que a gente tenha bons resultados no futuro. Então, deixo aqui à disposição, Mário, o Ministério do Meio Ambiente para contribuir com os trabalhos e parabenizo todos vocês por esse esforço, que eu sei que não está sendo fácil, é uma norma que tem aí diversas especificidades, características que não tornam essa discussão trivial, é importante reconhecer isso, quem conhece do tema sabe, ao mesmo tempo extremamente necessária para melhorar a gestão dos resíduos, extremamente necessária para melhorar a qualidade ambiental, e melhorando a qualidade ambiental, a gente melhora a qualidade de vida das pessoas. Muito obrigado e deixo aqui um abraço a todos os colegas.
Obrigado, secretário André. Realmente é uma satisfação muito grande ouvir suas palavras, ouvir essas novidades. De imediato, já aceitamos esse convite de apresentar os dois, porque hoje nós temos, nessa comissão especial que foi criada para resíduos, secretário, nós temos a participação de mais de 800 técnicos, entre iniciativa privada, governamental, academia e ONGs. Como estão sendo todas as reuniões virtuais, isso democratizou a participação. Então, nós estamos tendo mais de 800. E esse público, é importante esse público saber dessa grande novidade, além dos conselheiros da Abnt e das entidades todas que tratam, têm interesse nesse tema de resíduos. O segundo ponto, quero dizer o seguinte: pela essa ação, pela gestão que o senhor tem feito, está causando um problema no mercado. Né? Está faltando resíduo para reciclagem, secretário. Está faltando resíduo. Então, e o terceiro ponto, que aceitamos já de imediato esse pacto a partir de hoje. E vamos trabalhar junto, vamos saber, com certeza vai colaborar, e essa norma, nós pretendemos entregar antes do final do ano essa norma revisada, secretário.
Excelente.
Muito obrigado. Viu? Obrigado pelo seu trabalho.
Obrigado, parabéns a todos.
Obrigado.
Obrigada, doutor Mário. Agradecemos ao secretário André França. Agradecemos ao secretário André França pela participação. Informo que, por motivos de agenda, o presidente e o diretor-geral da ABNT precisarão se ausentar do evento. Mais uma vez, os nossos agradecimentos. Prosseguindo, convido o senhor Luiz Busato, coordenador da Comissão de Estudo Especial de Gestão de Resíduos Sólidos e Logística Reversa, a ABNT CEE 246, para explanar no painel 1 sobre o status da revisão da ABNT-NBR 10.004. Por favor, senhor Luiz, a palavra é sua.
Oi, bom dia. Quero primeiro agradecer pela abertura, a presença do Mário, do Ricardo e do secretário André. Também agradecer muito ao Eric aí pela disponibilidade do seu tempo para a gente poder estar fazendo esse painel. Vanessa, eu não estou conseguindo fazer o compartilhamento aqui da minha tela para poder compartilhar a apresentação.
Você está indo no share screen?
Aí, agora está liberado. Então, bom dia a todos. A minha apresentação será bastante breve, né, para usar o nosso tempo da melhor forma possível, aí com os trabalhos do Dr. Eric. Eu vou falar só brevemente, fazer uma introdução sobre como está a revisão da 10.004 e os trabalhos da comissão. Iniciando, a nossa comissão, ela foi criada, aprovada dentro do Conselho Técnico da ABNT no final de 2020 e instalada efetivamente em março de 2021, quando a gente começou os trabalhos dessa comissão. A comissão, ela tem lá uma definição na sua criação de âmbito de atuação. O que eu queria destacar aqui, né, que obviamente a gente trata de gestão de resíduos, logística reversa, os critérios da hierarquia do gerenciamento de resíduos, visando a sustentabilidade das práticas, e dentre as questões tratadas na comissão está a classificação de resíduos. Né? E pela natureza do tema, a nossa comissão tem uma interface com vários outros comitês de normalização da ABNT. A comissão CE 246, ela tem como objetivo a gente fazer, primeiro de todos, como já externou o Mário, o presidente, a gente fazer a mudança de paradigma da linearidade para o conceito de circularidade, visando sempre que possível a reintrodução dos resíduos dentro dos ciclos produtivos e econômicos. Né? O que a gente espera também é que as nossas normas traduzam o estado da arte do gerenciamento de resíduos. Isso é uma diretiva da ABNT e da própria ISO, né, que as normas traduzam o estado da arte. A gente está buscando aproximar as normas dessa questão. E fazer também uma atualização das normas antigas e, ao fim disso, disponibilizar para a sociedade e todos os atores que atuam na cadeia de gerenciamento de resíduos, inclusive os órgãos ambientais do CISNAM, um conjunto robusto de normas técnicas. Eu fiquei falando brevemente de como que o perfil dos trabalhos da nossa comissão, né? No ano passado, a gente estava com 386 participantes ali no Live Link, que é o banco de dados da comissão. A gente fez 27 reuniões de trabalho, reuniões técnicas no ano passado, que contaram aí com 1.680 participantes, né? Uma média de pouco mais de 60 pessoas por reunião. Foi um trabalho bem árduo e mostra como que está sendo a dinâmica da nossa comissão. Quais são os impactos esperados para essa comissão de estudo? Né? A gente fazer um trabalho de simplificação, modernização e valorização das boas práticas do gerenciamento de resíduos, né? Criar uma base técnica padronizada para todos os stakeholders e para as políticas públicas. Eu queria reiterar esse ponto, que é muito importante, porque são conceitos e palavras e temas chaves que a gente usa e que, às vezes, eles são disseminados, né, de forma distinta e, às vezes, em instrumentos legais ou instrumentos, e isso causa uma certa dificuldade, e a ideia da norma técnica é justamente fornecer um padrão para que todos possam adotá-lo, e a gente está falando de forma uniforme, não sermos uma torre de Babel, né, quando a gente está tratando das normas. O outro ponto é a gente fazer um apoio à sustentabilidade no gerenciamento de resíduos. Como já destacaram aí o presidente e o secretário, a gente fazer um trabalho que reforça a reciclabilidade, a circularidade e o potencial de aproveitamento energético dos resíduos. E também temos que fazer um processo que isso resulta na ativação das cadeias de negócio, a partir também, de novo, como a gente falou, de um sistema padronizado, de termos padronizados, de referências normativas padronizadas. Isso favorece que as cadeias de negócio realizem suas atividades de forma segura, né, e padronizada. E também temos aí uma questão que é a redução dos desvios de fraudes, desvios e fraudes na destinação de resíduos, que a gente considera importante. A estrutura da nossa comissão, ela tem 6 grupos de trabalho, né? Está trabalhando com mais ou menos 30 normas técnicas, e a questão da classificação de resíduos está no GT2, né, que trabalha a classificação de resíduos e amostragem. Então, o que nós estamos hoje discutindo está aqui no GT2. Bom, aqui também, para praticamente finalizar aqui essa questão da comissão, a gente tem os trabalhos que estão em andamento do ano passado. O primeiro que eu gostaria de destacar é a nova norma NBR 1728, foi publicada agora, né, 31 de janeiro desse ano, que trata da destinação de resíduos sólidos perigosos para fins energéticos, né, os requisitos aplicáveis a essa destinação. Além dela, nós estamos trabalhando na revisão da 10.004 de classificação, que é o tema de hoje, e na revisão também da destinação de PCBs, NBR 13741, e uma nova norma de gerenciamento de resíduos, que é essa questão da padronização e uniformização da abordagem ao tema. E o que nós temos aí no horizonte desse ano, de 2022? Né? A gente publicar essa nova norma de gerenciamento de resíduos, provavelmente no primeiro semestre ela vai estar pronta para consulta pública e publicação. Também finalizarmos o processo das outras 2 citadas, e fazemos ainda mais avançarmos aí nas normas de armazenagem de resíduos e aterros, e algumas normas de temas mais técnicas, né? Normas técnicas de temas mais específicos do gerenciamento, como a questão da rastreabilidade. Dentro desse trabalho que a gente está fazendo na nossa comissão, né, a gente optou por alguns temas dar maior visibilidade e ampliar o debate, e temos feito algum webinar. Nós fizemos um webinar sobre PCBs, com o apoio da CETESB, em dezembro, né? E hoje estamos fazendo esse segundo webinar, que trata da questão da classificação de resíduos. Bom, então, para eu poder introduzir o assunto do Dr. Eric, que vai abordar, né, a questão dos critérios de periculosidade e classificação de resíduos, antes disso, só queria explicar para vocês como que a gente está trabalhando. A gente está fazendo a revisão da norma e temos um cronograma de trabalho. Em junho, a gente pretende já ter fechado a lista de resíduos que vai constar da norma. Em abril, a gente fechar a avaliação dos critérios aí que há mais consenso, mais facilidade na tratativa, que são os critérios de inflamabilidade, reatividade, corrosividade e patogenicidade. E em agosto, a gente quer fechar os critérios de toxicidade, que é o grande debate que nós teremos hoje, né? E em setembro, aspectos do ensaio de lixiviação e solubilização, que hoje estão previstos na 10.004 também, e que está totalmente relacionado com a questão da toxicidade. E fechando todos esses pontos, em outubro, nós fechamos a revisão da norma. Então, passando aí para falar da 10.004, até introduzindo o assunto, né, para a gente ter um direcionamento, a nossa norma surgiu, a primeira norma, de setembro de 87, né, a primeira norma de resíduos, ou seja, no começo do processo de regulamentação ou de definições normativas já teve essa norma ABNT. E essa é uma particularidade muito interessante, que no Brasil os resíduos são classificados conforme uma norma ABNT. E essa norma sofreu uma revisão em 2004, e agora estamos num novo processo de revisão dessa norma. Quando a gente está falando de resíduos perigosos, o que a gente está querendo dizer? Né? Existem duas definições. Né? A primeira definição da própria 10.004, né, que ressalta a questão que são aquelas que o resíduo que apresenta características, né, que podem apresentar risco à saúde pública ou ao meio ambiente, e a gente tem a indicação da Política Nacional de Resíduos Sólidos, né, que ela fala que aqueles resíduos que, em razão das suas características de inflamabilidade, corrosividade, reatividade, toxicidade, patogenicidade, carcinogenicidade, teratogenicidade e mutagenicidade, apresentam também o risco à saúde pública e à qualidade ambiental. Então, o que nós temos aqui hoje no Brasil sendo aplicado? Né? Temos o critério de saúde pública, de risco à saúde pública e ao meio ambiente, como critério de definição do que é um resíduo perigoso. Isso está uniformizado até nessas duas. Elas não conflitam entre si, elas estão falando a mesma coisa, só usando termos diferentes. E temos aqui uma definição de quais são as propriedades físicas, químicas ou infecto-contagiosas que indicam se um resíduo é perigoso ou não. Na política, um pouco mais detalhado, os itens que devem ser levados em conta. Né? Mas eles estão abordados dentro da 10.004, como eu vou discutir a seguir. A 10.004, a versão 2004, ela traz listados da seguinte forma: os critérios de inflamabilidade, corrosividade, reatividade, toxicidade e patogenicidade. E dentro do critério de toxicidade estão ali o conceito de efeito adverso, que é aquele efeito de tóxico, de eventualmente até causar a morte, ou carcinogênico, ou mutagênico, ou teratogênico, ou ecotoxicológico. Né? Então, essas são as definições que estão aqui dentro da nossa 10.004, a forma que ela está organizada hoje. Né? E aí, essa questão do resíduo tóxico, como que ela considera um resíduo tóxico? Ela considera um resíduo tóxico, né, quando o ensaio de lixiviação, ou seja, a nossa classificação de toxicidade leva em conta o ensaio de lixiviação, que a concentração de determinadas substâncias que estão listadas lá no anexo F sejam maiores do que aqueles limites que estão lá estabelecidos. Né? Essa listagem traz 9 metais, 12 pesticidas e 4 substâncias orgânicas. Né? Então, se estiver acima daquele limite do lixiviado, é considerado tóxico. Né? E fala, ou, né, possuir uma ou mais das substâncias do anexo C da norma e apresentar toxicidade. Ou seja, aqui não há limites para substâncias, concentrações das substâncias do anexo C, e a questão é essa: o que significa o apresentar toxicidade? Então, essa questão de apresentar toxicidade, que na norma leva a uma condição um pouco sui generis. Né? Essas substâncias do anexo C, elas depois estão divididas em anexos D e E, que em substâncias agudamente tóxicas e tóxicas. E o que acontece? Qual que é o nosso problema a gente resolver hoje? Né? É que, na prática, né, a toxicidade acaba sendo avaliada somente pelo ensaio de lixiviação. Os anexos C e D e E, que são praticamente a mesma listagem do C, só que desmembrado em substâncias agudamente tóxicas e tóxicas, não são aplicados na prática, com raríssimas exceções. Então, nossa classificação de toxicidade, um dos critérios de classificação do resíduo, é baseado exclusivamente ou genericamente pelo ensaio de lixiviação. Bom, essa base que a gente usa na 10.004, ela vem lá da norma da EPA, né? Então, mais especificamente da subparte D, né, da parte 261, né, da parte que trata dos resíduos sólidos. E no caso europeu, né, a norma europeia que versa sobre o tema é a Diretiva Europeia 2008/98, que vai ser amplamente discutida aí pelo Dr. Eric. E essa norma está alinhada à OCDE. Né? Então, a gente falou aqui, né, o presidente falou sobre a importância da gente estar alinhado aos conceitos da OCDE. Enquanto o conceito americano, Vale lembrar que os Estados Unidos não é signatário da Convenção da Basileia de Estocolmo, né? Então, aí que a gente tem algumas divergências. E a gente tem todo o desafio de conhecer esse sistema europeu. Se a gente está acostumado com um sistema, parte do sistema americano, a gente tem pouco conhecimento de como funciona o modelo europeu. E para isso nós temos aqui hoje a presença do Dr. Eric, para quem eu passo direto a palavra para fazer a sua apresentação a respeito. Eu agradeço a todos.
Obrigada, Sr. Luiz.
Thank you, Luiz. Good morning.
Obrigada pela excelente apresentação.
Yes, Vanessa.
Dando sequência ao webinar, ouviremos o Sr. Eric Weinberg, gerente de advocacia e saúde da empresa Geocycle Europe, que apresentará no painel 2 o modelo europeu de classificação de resíduos perigosos e não perigosos.
Eric, the floor is yours.
Thank you, Luis. Thank you. Buenos días a todos. I'm sorry for my poor Spanish, Portuguese. Sorry, second time today. Please do not hesitate to interrupt me during the presentation. It's open for any topic. There are no bad questions. All questions are relevant. So please don't hesitate. Raise a question when you want. I have a small presentation for that. Let me see if I can present it. Do you see my presentation?
Yeah, we can see it.
Okay, so I hope it will work like that. So we have, I don't know how to cancel all this. If I take all this out, and I cannot take this completely out. Sorry.
Yes.
No, I cannot take it out. Sorry. So we have in Europe a regulation, and you have there the link where you can find it immediately in Portuguese, which is fine for you. The first point is to define to what kind of material the regulation applies. And for that, we are speaking about waste, we are speaking about byproducts, we are speaking about waste that leaves the waste status, and we have to say to what it applies. When we are speaking about byproducts, we have to know that some examples. It is something that you are automatically producing, but not intentionally produce. The example I give there, if you are producing electricity with a coal-fired power plant, you will always have the fly ashes from the coal. You do not want to produce the fly ashes, but you cannot avoid it. The same with the slags from a steel blast furnace. You cannot avoid it even if you do not intend to produce it. And you can find a lot of examples. The olive pits, if you are producing olive oils, is another example in a completely different topic. Now, you see there the conditions when a material could be classified as a byproduct. As I told you, it has to come from a production process, but not intended. It can be produced, it can be used immediately in another substance, in another process, and it works without any problem for the environment or the human health. These are the main points. It means you can have a byproduct. Fly ashes, for example, are used in cement plants to produce SEM2 quality fly ash, cement. But if you don't use the fly ashes in the cement plant and you put it in the landfill, whatever, then it is a waste. So you can have the same material, which is a byproduct if it is used compliant with regulation, and if it is a waste, if it is not used compliant with the regulation. That is to be clear as well. And we have also wastes that are leaving the waste status. So the example is when paper is collected, sorted, and ready for use in a pulper to make new paper. the quality is fine for the paper industry, then it is considered as being an end of waste. It's the case for metal scrap as well. It can be steel scrap, copper scrap, whatever. If it fits with the standards for reuse in the, can I put this away? Yes, it will be better like that. If it fits for the standard to be used in the steel industry, then it is fine. It can leave the waste status. The same for glass skeletts, but once again, it is not automatic. We have two examples, glass skeleton and metal scrap, which is at European level, but the other, it depends on the regulation of the country. So it can be that one country is saying it's a waste and another country is saying in Europe it's end of waste material. Important, if you have a waste that is leaving the end of waste, if it is leaving the waste status, it has to be registered under REACH, which means we need to know what are the different components, and we need to know if those components are hazardous or not. Be aware that in paper, you can have hazardous substances even if you don't know. I'm thinking about packagings for food. Usually it is treated with PFAS so that the paper rejects and the moisture and the fat. PFAS are very stable. It's now a POP. It means the paper that is recycled with that could be problematic. The same if you have, for example, the paper coming from the printer of when you go shopping. It's a thermal paper. A thermal paper contains also components that we do not want, that have been forbidden for food for children, for example, but you can find it in paper, so you will find it back in recycled paper as well. So we have to know that these are examples that could limit the end of waste status of some paper. And then when you look, you have some examples I took here. When you are recycling granulates of concrete, you have to look to the contamination. A single example is, for example, the presence of asbestos, which could make granulate hazardous. It can be a granulate coming of an old fabric, an old plant, which could contain some specific pollutants due to the former activity of that plant. You spoke about PCB, it can be PCB, it can be metal, it can be whatever. The same is valid for compost used as fertilizer. You cannot use a compost as fertilizer if it contains pesticides, if it contains unwanted material, if it contains metals that could have an impact on the quality of the food, especially in the context of bioaccumulation. And another example I have there is soil. We have in Europe a lot of, due to history, we have a lot of sites that are completely polluted. When the soil is activated, it can be cleaned thermally with batteries, whatever. But then we have to decide what to do with that soil. We will not have the same quality if it is for an industrial purpose or if it is for a place where children will play. This is where we have different limits. And you see again, we have a lot of byproducts that could be used as fertilizer, but again, we can find their limits for metals. If you exceed the limits, you cannot use for certain application. The same for pollutants in the wastewater treatment sludge, which is used in agriculture, where we have an old regulation on that, which was only considering the heavy metals. But today we see that in the wastewater treatment sludge from the municipalities, we find pharmaceutical products, we find endocrine disruptors, we find microplastics, we find PFAS. So we find a lot of pollutants, and we know that all those pollutants will have an effect on bioaccumulative effects, and we will come back in the food chain. This is why the wastewater treatment sludge in Europe is less and less used in agriculture. And at European level, we are now looking to reduce that use, which means we have to find alternative for the sludge, which is now used mainly in the cement industry as well, because this is the biomass. When it is dry, this is the biomass, and it is raw material as well. It contains sand, it contains calcium, it contains things we can use in the cement industry as raw material and energy. Now, if we are speaking about pollutants in soil, for example, each country of each region has its own regulation. And it depends, as I said, where it will be used because of application, but it will also depend on the background of natural soil. We have in some regions clay and sand. If we put there remediated soil that contains stones, it is not normal. But if we put a soil that contains stone in a region where there is a lot of stones, this doesn't matter. The same for metals. We have regions with poor metals in the soil. In the ground, we will take care that we have poor metals in what we put there. But if we have other countries where we know, for example, we have chromium in the ground, why should we apply a very, very strict limit for chromium if it is still present in the ground? You see, this is where we have to adapt the regulation due to the local circumstances. Now, one of the topics today was to speak about hazardous or non-hazardous. The first point, we have a specific regulation for that, which is defining, which is the code of waste, list of waste. And the purpose of this list is to ease the classification. It means you have a list where some materials are considered automatically as hazardous, and you see there the old list of the POPs, which you find back in the Stockholm Convention. And you see all type of activities. I gave you there some examples. If it is a code like 03, 01, 01, and without a star, without an asterisk, then it is considered automatically as non-hazardous. If there is a star, it is considered automatically as hazardous. So in that case, it is quite easy for a producer, without making any analysis, to say, well, that one is non-hazardous, that one is hazardous. That's easy. You find your ways there, and you can say it is hazardous or non-hazardous. But you can see that we have also what we call mirror entries. Mixture of waste containing residue, hazardous residue, and mixture of waste containing no residue, or just being the opposite. In that case, you have to check what it is. In that case, you have to make analysis or to make tests for that. So we have, in fact, in the list, cases where it is automatically non-hazardous. We have cases where it is automatically hazardous. And then we have those mirror entries where we have to define based on the parameters, the technical parameters. In the case of mirror entries, there are some points helpful. The origin of the waste. If we are speaking about cans that have contained phytopharmaceutical products, automatically we will classify them as hazardous. If we are speaking about sludge contaminated with oil, whatever, automatically it is hazardous. If you are taking sawdust that or textile that is being used to clean waste oil or oil sludge, automatically it will be classified as hazardous. You don't need to make analysis. But in other cases, you will need to make analysis. Example, the flash point, and example, the ecotoxicity. For the ecotoxicity, you can use, if you know, the components and the properties of the components to see if it is hazardous or non-hazardous. But I will give you a strange example. Zinc oxide is ecotoxic, as from 1%. In a tire, in the rubber of a tire of your car, you have 2% of zinc oxide, which means that logically, the tire of your car should be considered as ecotoxic if it is about waste. But we all know that the zinc oxide will remain in the rubber. So an ecotoxicity test, which is done with Daphnia or with algae by bioluminescence, will show if it is ecotoxic or not, and this test prevail on the analysis. And we have there a regulation about what do we have to consider as hazardous properties. I hope I'm not speaking too quickly for the translation. Now, we are using, like in the United States, the global harmonized system. And we are looking per propriety, per hazardous properties, what do we consider? We have the molecules and the properties of the molecules, and we have a limit, which is a limit under which you do not have to consider that molecule. This is just to avoid that we have to go up to the last detection possible, depending on what is the technique that you use for analysis. And you see there examples where we have to make sum of components, but if some components showing, for example, the property H300, the concentration is below or 1%, which is 1000 ppm, you don't have to consider it for two reasons. Or it is in very low concentration, or it is difficult to determine the exact concentration of the material because of the detection limit, but also because of the variation of the sampling of the waste. You have another example here where you see that depending on the toxicity of the molecules, we have different concentrations that are considered as presenting that property. If it is above 5% for the H301, then it shows the toxicity number 3. You see, in that case, again, we have limits under which we do not consider the molecules. And we make sum for others. For carcinogenics, mutagenics, and reprotoxic, it's not the sum that we use, but it is the main components. So if we have one component which is H360 in a concentration of 0.3% or more, then the waste is considered to be reprotoxic. This is the way it works. So we have here sum, and we have other cases where we use the maximum, the main molecules which present the property. Now, we are also facing the problem of the concentration of each constituent. How do we do that? How do we measure it? It's especially difficult with solids, but you will see also with liquid it can be difficult. We have to know what are the hazardous properties of each substances. And we have in Europe the ECA website, which is updating each month the knowledge that we have about each molecule that we use. So what are we doing? We are summarizing what we have as information from ECA, and you see just an extract of it. You can see what are the hazardous properties of one molecule with the CAS number. We are making an analysis. We extract the components and we make an analysis, and we see an ID. It's not the exact value, it's an estimation of the concentration with 5 or 6 standards that we are using. We have the numbers, we have the H properties. And when you have something like that, you can also compare by making sum and comparison. If the waste presents, you see the column on the right, if the waste present 1 or more, it means it is above the concentration that has to be considered as presenting the hazardous properties. And so you can see if one waste is, in this case, not irritant, well, toxic by inhalation, no toxicity ague 1 or 2, but toxicity 3, yes, and it's also carcinogenic. That's, I will not say it's easy, because it depends how you measure. It depends how you measure, and you see there the concentration. We have there one component not non-identified. That's great. So we had discussions some years ago with the French government, the French Administration for Environment, and they were saying, well, if you don't know, it is automatically hazardous, and the waste should be classified as hazardous. We have been able to show that it is not identified in most cases. It is a non-hazardous component, because it is easier to find with the GCMS what are the hazardous components than a non-identified components. Also, usually, the hazardous components are smaller molecules than big molecules because of exposure. Simply like that. This is something we have put in place in our plans to see if a material is, if a waste presents some hazardous properties. Be aware, those rules apply for waste and not for products. Which means as soon as you say it is not a waste anymore, then you have to apply the normal rule and testing for products to be sure that the product complies with the same hazardous properties. And let me see, come back. So we don't have all substances, unfortunately, but you know, take a piece of meat. Before you know all the components in a piece of meat, it will take you months of analysis, and we have to be practical somewhere. We don't have specific research on pop. With the exemptions of PCB, we are measuring, we have standard for PCBs where we are measuring usually if we are below or above the 50 ppm, like it is prescribed in the Stockholm Convention. If we have suspicion of specific pollutants, but in small concentration, dioxins, PFAS, hexachlorobenzene, pesticides, whatever, then especially in solid, it is difficult to extract them. Then we send it to an external laboratory, which will make an extraction with a hot solvent, reconcentration, and GC-MS to identify them. But most of the laboratories of the companies are not able to measure those very small levels. We are speaking in microgram, nanogram, picogram. This is not something that the standard laboratory for waste is able to measure. And we have also the possibility to estimate some pollutants by indirect parameters. We receive polyurethane from the recycling of old fridges. And we know that the polyurethane of the old fridges that have brominated flame retardant, hexachlorobiphenyl, pentabromobilphenyl, and things like that in the foam, insulating foam. It is difficult to extract the brominated flame retardant to make an analysis of it, but it is easy with a colorimetric bomb to mineralize all that material and then making analysis of the bromine content to see if it is or not a brominated plastic. The same exists for the polyurethane, for example, with fluorine, because in the past they have been using Freon to expand the foam. So if it is pressed and the Freon is taken out, you will find a poor fluorine content. You don't need to go into detail of the molecules. The global total fluorine content is a good parameter for you. This is also used as a criteria to consider it is hazardous or non-hazardous. Be aware, and the authorities are also aware, that it is impossible to analyze all components. And so we need to find somewhere a good practice. Yes. It's also a purpose to say if it is hazardous, non-hazardous, but it doesn't mean that it decides with that what you can do with it. Can you put it in the landfill? Can you reuse it? Can you recycle it? It depends. In that case, you will need more tests. For example, the leaching behavior is important if you will landfill the material. It is important if you will store it outside before you recycle it or reuse it. Because if it is raining and you have leaching behavior, then you could pollute the rainwater and the underground water. We have also other parameters for landfill. For example, in most of the countries in Europe, it is now forbidden, it should be forbidden to put in landfill material that contains more than 6% of total organic carbon. Because in countries where we have enough incineration capacity or co-processing capacity, we say, well, it's nonsense to bring that material in a landfill. Because if you put it in the landfill, you will also induce fermentation, methane production, and things like that. So it can have an impact on the emissions. It can be an impact on leaching behavior. And we have also to consider that depending how you know the material that you have, you can also limit the risk of chemical reactions between waste streams. If you have from time to time reaction between waste streams, this can be extremely damageable for the environment and for the health of workers and the people. The more you know about the waste, the more you know about the potential exposure of the workers, the more you know about the potential exposure of the neighbors, which means you can adapt the control of the health of the workers by blood, urine, whatever. It's important. It's also important when the workers and the local stakeholder knows very well how you manage waste, even hazardous waste, even very hazardous waste, you get confidence. If you get questions and you do not know what it is, well, nobody will trust you, nobody will believe you, and the risk of accident increases drastically. I didn't spoke so much about metals. We have some metals which are easy to determine, and I've seen in the presentation before that you are speaking about 9 metals. We are looking to much more metals because you don't know under which form the metals are in the waste usually. It can be in a no problem form, I would say. It can be in carcinogenic form, it can be in corrosive form. It can depend where you find the metal. If I am speaking about baths from galvanization, obviously I will find zinc chloride, iron chloride. If I find chromium and lead in paint, obviously it will be lead chromate. So that's easy. But in a lot of other cases, you do not know in which form the metals are. And so it is difficult to say only by knowing there is so much ppm of lead that it is hazardous or non-hazardous. It depends also on the form. In Europe, we are making a distinction now, for example, for lead or titanium dioxide, saying if it is in a dispersible form, then it is hazardous. If it is in a solid form, then it is not hazardous, because there is no risk of inhalation, there is much less risk of dispersion, and this is the kind of difference we are doing. You are speaking about the standard. You know that we have a standard for solid recovered fuel since many years. Now in Europe, it's about 15 years that the standard is applicable. And Luis has said that it is also working at the ISO standard. We are now making ISO standard out of it. It gives you an idea how to prepare a sample, how to sort sample, how to make an analysis, how to make the metals by XRD or ICP AAS. It gives you an idea how to measure the biomass content. It's fine. Only that standard cannot always be applied to any kind of waste. Just a single example. If you measure the biomass content by a selective dissolution, you are dissolving the biomass. But if in that material you still have solvents, well, you will dissolve the solvents, but it doesn't mean it is biomass. And some material will not react correctly as well. So there are limitations in the application of the standard. I don't know what to say more about that. I think it's more now for you to raise questions on what we have, because we have so many different kinds, different types. Just be aware that out of the classical hazardous properties, Europe is now thinking to add a new one, which is endocrine disruptors, because this is something which is more and more working on the health of the people, and we see more and more effects on that on the long term. This is why we are now looking to have that new hazardous properties that you can find in a lot of materials like PCB, like dioxins, like PFAS. It's coming in a lot of material as well. That was it. I don't know. I'm open for any question now. I don't know if it complies with your expectation. If you want to have more information, please, the floor is yours now.
Thank you, Eric, for your presentation. It was great, and I'm sure that people is full of questions. I still have questions, but just about this topic you just mentioned about endocrine disruptors. You mean it will be like a new age code, something like that?
Yes,
okay.
That's the intention. To give you an example, in Europe, we have a lot of women that are taking pills for contraception. When they go to the toilet, obviously, the hormones are going to the water. They are going to the wastewater treatment station, and they are not captured in the treatment station, which means they are going to the river, and the concentration is sometimes so high that the fishes are changing of sex because of the concentration of hormone that we have. I spoke about the PFAS that we have. It is easy. It is what you put on your shoe to make your shoe waterproof. This is also an endocrine disruptor, which has three effects. It attacks your liver, it reduces the dimension of the fetus, and what is the third one effect? I don't remember exactly, but it has three effects on your health, including endocrine disruptor. So what do you do against those molecules? You cannot classify them in another class, but you know they have an effect on the environment and on your health. So where do you put them?
Yeah, I would like to raise some questions. The first thing is that the classification system you have in Europe, it seems that you can classify the waste in this case according to the concentration of substance. I mean, you say you check the concentration of the main substance to reach the to know if it's mutagenic or carcinogenic.
Yes.
You don't carry out, or rarely you carry out a test of mutagenicity. You just mentioned ecotoxicity.
So long it is a waste. When it is becoming a product again, then you have to do the test. Or you have to make, if you don't do the test, you have to know that you have a certain concentration in the new product, and then you can classify that new product based on the concentration that you have. Yes.
So what I mean is that the classification is done by the concentration of substance, not by very complex tests.
Yes.
Okay, I have another single question. There are some questions coming in the chat, but I have a very specific question. You said that it's not easy to classify, but is it easy in terms of establishing a specific methodology to apply for that? Obviously, you mentioned if it's a liquid or if it is a mixture with solvents, as you exemplified. But can we apply some analytical procedures, 1, 2, or 3, that will come up the answers to classify the substance, like the example you showed, the spreadsheet you showed for us? Could we have single spreadsheets to come up like a flow diagram and to come out with the classification?
Yes and no, because it depends what you intend to do with the waste. If it is prior to landfill, then you have to make leaching tests as a priority. If you are thinking about recycling of construction demolition waste, I will say, well, what is the presence of all pollutants from depending where it is coming, or from asbestos, for example. Or they will have a look if it is going to landfill, what is the pH change. And you know that if you have some gypsum in the material, you will also have some leachability of the gypsum, it means that you will have too much sulfate in the water. You see, these are the kind of things, it depends what you intend to do with the waste. So we have the waste non-hazardous, you have the waste hazardous, and then you have the test have only to be done when you have doubts. Now, if you know that there are always exclusions. I will give you an example. If you say it is flammable for a flash point below 60 degrees, that's easy, okay. But this is not enough, because if the material is delivered hot above its flash point, which is above 60, then it is also flammable. You see? Because then you put in a hot phase that will burn as well. So there are always exemptions to anything. You have metals, cadmium, mercury, it's always hazardous. For other metals, it depends on the form of the metals. Chromium 6, chromium 3, it changed. But if you have mixture or everything, how do you know under which form each metal is? Is it a chloride? Is it a sulfate? Is it something else? Is it a complex matrix? You don't know, and you will never know. So it is difficult in those cases to say these are the hazardous properties of that material due to the metals. And we have to work with approximation. When we are discussing with the ISO, with the SEN standard, European standard, so we are always facing people that are trying to have the best possible analytical solution. That's fine, but be also aware that the sampling, due to the heterogeneity of the waste, is also introducing much more uncertainty on the result than what you can have due to the analysis. And this also has to be considered. Huh? And this is also why Europe is saying below 0.1%, below 1% the components. Don't search too much, because unless it is hazardous like dioxin, things like that, it doesn't make sense. You never stop with analysis. And somewhere we have to be practical.
Yeah, we will come back to this question of being practical. I will give the opportunity to raise some questions that people add to the chat, and there is also a friend who raised her hand to speak. But first, Tasso Cipriano sent a question for us. It's written in the chat. Dear Eric, thanks for your time and presentation. As for mirror entries, who decides when testing is a must? For mirror entries, where testing is not required, who decides whether to apply the origin or composition criteria? To be sure, is this something the WFD itself addresses, or rather member states?
In Europe, it is the producer of the waste who is defining what is the waste code that applies to its waste. But as user of the material, you will have to check if it is somewhere logic. I had some years ago somebody presenting me railway sleepers, wood, contaminated wood, okay, with 3% of cresol. And I go on the ECA website and I see carcinogenics from 0.3%. So the guy was saying not hazardous, and I was saying it's not possible, because with 3% of cresol, it is automatically 10 times above the limit to make it carcinogenic. You see? So we have to. One other was coming about with soap, and I said non-hazardous. So it's fine. And I said, wait, yes, but guy, 94% of the components are irritant. So you cannot classify your soap as non-hazardous if 94% of the components are irritant. So be coherent. You see? This is somewhere where you have to find a compromise. The responsibility is to the producer, but as if you have an installation for a landfill, if you have a cement plant, if you are an incinerator, whatever, and so you have to check if this makes sense, what they are telling you.
I have a question. But in this case, is there an official statement or something like that? Which kind of document must have this to ensure the classification? Is there any official document or not?
In some countries it is, but it's not general. And we have also companies that are protecting themselves and their responsibility by asking the producer to fill in documents where he says, well, there is no PCB, there is no carcinogenics, there is no POPs, there is no dioxin, and things like that. So that you can also have an estimation. And if something is wrong, you can also go back and say, guy, you told it was not in, and during control, we see it is in. You see, that's the way we do as well. It's also difficult to compare. You don't have to see Europe as something homogeneous. If I am speaking about Western Europe, and I'm speaking about municipal solid waste. In Western Europe, we have selective collection for the paint, varnishes, for the electronical part, for batteries, for all kind of hazardous substances. So there are selective separate collections. If you go in eastern part of Europe, I would say the awareness is less educated, and so all batteries and everything is going in the municipal solid waste. So if you are speaking about municipal solid waste, it's not the same concept, depending on the country where you are and where the authority have put a level of selective collection and separate sorting and recovery of those waste. That's one of the problems we face. It's not homogeneous.
Okay, thank you.
It's the same, just to give you another example, it's the same about wastewater treatment sludge. In Western Europe, since many years, dentists have been obliged by law to put a trap for mercury. So that with that effect, we have seen a drastic reduction of mercury in the wastewater treatment sludge. In eastern part of Europe, this is not yet mandatory. And we see that in those countries, there is much more mercury in the wastewater treatment sludge. You see just some measures can transform completely the components of the sludge. You can also, when you're speaking wastewater treatment sludge, is it just municipal wastewater treatment sludge, or are some industries also connected to the same sewage system? Because then you can have much more other pollutants, organic or metals.
Okay, thank you. I will give the open to Lucia. She wants to make a question. Please, Lucia.
Thank you, Eric, for your presentation. I am Lucia Xavier from the Center for Mineral Technology in Brazil. We are doing some research on circular economy and urban mining. And in this respect, I would like to mention about 2 points you have presented here. This Q&A session will be very important for us, I should mention by now. You mentioned about the European Chemical Agents, the website. So you have the CAS number. I would like to ask you at first two questions only. The first one, it's about this CAS number, if it's adopted outside Europe. Do you know any country that is using this CAS number?
I think it's worldwide. I think it's also in the US that they use the same CAS number, because these are international chemical numbers. So it should be the same number in the US or in Canada than in Europe than in China.
Oh, great. Maybe it could be a tip for us to think about this adoption of this
if you are speaking about recycling or aggregate, whatever, and so we have 2 things to consider: the total composition and the leaching behavior.
Thank you.
And we make a distinction between granulates that are coming for plants that could be contaminated with asbestos, or plants where we know that asbestos has been taken out before dismantling.
Okay, so the second question will touch this. I would like to mention about the TC323, where we are working in the circular economy standardization, and we have a working group, the GGG14, where we were working on secondary material. So in your speech, you mentioned about the producer is responsible for the test about the hazardous, about the material. So when we are talking about products, and sometimes we are talking about material. And my point here is about the secondary material, as much as it has short circles and it enter again in the production line. So when, the first question, when you should test it? And the second point, it's about, will we move from the end of waste to the secondary material? It would be work together, or it's completely different? Thank you.
If you are dealing with construction demolition waste, which is what you are speaking about, we make a distinction if it is coming from streets, from railways, from houses, from buildings, industrial buildings and things like that, which gives you an idea still of a potential contamination because of the origin. One of the first operations they do is what we call a pre-scalp, which means they are first sieving the fine fraction, which can be a little bit of plastics, a little bit of copper wire, it can be some ground, which can be some soil or some fine fraction which is taken out with gypsum and everything. This is a fraction today they do not know what to do. It is going to landfill with an exemption by the authority so long there is no alternative, because we know that there is a too high sulfate leaching. So today, because of quantities and because of just that problem, the authorities, okay, we gave a derogation year by year, so long you don't have a solution. But we are pushing you to find a solution. And then you have the rest. You have bricks, or you have concrete, or you have stone, depending on the region you are. If you have bricks, this is a granulate which is not a very high value. You can use it for tennis courts, but it's a very restrictive solution. So you have to find other alternatives. And one of the alternatives we have in Europe is to use it as a substitution of the clay in cement plants, because it's just cooked clay. And it helps the cement industry to reduce the decarbonization CO2 emissions. If you speak about concrete, stones can be recycled as stone, not a problem. If you speak about concrete, we have a standard which allows, depending on the application, to put 10 to 20% of granulates of concrete in new concrete, which is not so much. So today there are tests which are done to see if we can recarbonate the concrete granulates at the surface so that they get less porous, and then we expect to have a standard that could go up to 30, 40, 50% of granulates. And when you are crushing the concrete, you get a fine fraction. The fine fraction can go back to the cement industry because it is also partly decarbonated, or it is used also in Europe as a filler for asphalt, for road construction. This is a little bit what is happening in Europe with all of that. Again, you have the responsibility of the producer, which is the one who is dismantling, demolishing a building, and you have the responsibility of the plant that is crushing, preparing the material, because he has to ensure the quality, which is fine for reuse. The responsibility when it leaves the waste status is the responsibility of the one which is preparing the aggregates. Does it fit your question?
Yeah, in part, thank you. But by this time we are working with e-waste, electronic waste, to recover material, and also critical material. This is the point. We have the critical material regulated now, recently in Brazil. And the point is, as much as I have a mobile, it was end of use and not end of waste. And the idea is to produce materials, recover material, from these products. And I would like to know if in Europe, the final question for my colleague to continue, and I would like to know if in Europe they are thinking, because in this committee we are discussing not end of waste, we are discussing a secondary material. And my point here is if it's shocking in Europe also, these both terms.
When you have electronic material, it is usually considered as hazardous because most of them are still containing some hazardous components. When you dismantle with the crush, you separate the different fraction. The first problem we are facing in Europe today is the ion lithium batteries. We find them everywhere, and it is extremely hazardous. It provokes fires everywhere in the recycling process. When you are going to the other components, I have to say one of the main problematic points is the plastic, because you have a lot of flame retardant in the plastics. So that part cannot be recycled as such. That's unless you have other applications where you need a fire retardant, but flame retardant, but these are exceptions. And it can only become a secondary raw material when it is entering the recycling process in the metal industry, not before that stage, because there are so many different components all being hazardous. We don't want to separate them. You can have some fractions which are non-hazardous. I was giving further the example of all the fridges. When you take out, you dismantle the fridge, you take out the oil, you take the gas out of it, then you can recycle the steel, you can recycle the alumina, you can recycle the glass, you can recycle the fine white plastic that you have, but inside you have the polyurethane, the insulation. That one you can recycle. So when you have taken the gases out of it, then you can consider this not hazardous anymore. So then you can split between fine, non-hazardous and hazardous fractions. Be aware that in the old fridges, you often have a condensator which is still containing PCB. And we see that when we have a metal shredder that are using electronic material, they have higher PCB emission than other shredder. Be aware of that as well.
Thank you so much, Eric. Thank you.
Please, Lucia.
Okay, Eric, I will make another question. We have just to let everybody, sure we planned a long questioning period, just because the debate is the most important part of this panel of today. Obviously, you can briefly give a break, make a short interval soon, but we have two questions here already. One from Luisa Cirne. I will give it to you, Eric. And then Fabriciano raised his hand and wants to make a question. First, Luisa. Dear Eric, is there any specification or classification system to organic wastes and in terms of composting? Something like that?
Yes and no, because this exists at national and regional level. We have some parameters at European level, but very few, and most of the parameters are defined at regional or national level. I can try to find you some information on that, Luis, to give you some example.
Okay, but in general, just to add for the point, in general, composting, the material from composting, here in Brazil, we have some regulations. They set some limits for metals or things like that, as we mentioned before, and yes, that's it. I guess it's the same principle.
We have different rules which are also considering what you put in the composting installation. You cannot put hazardous waste. You cannot put waste that will bring unwanted material. You have also limits, for example, in the piece of plastics you can find back in the compost and things like that. So, because if you have no limit for that, they are dispersing again plastic. So, but the main driver for that is the input material that defines the quality of the compost you can have and what at the end what you can do with it. You can have a bad compost quality that you can only use as a cover surface of landfill and nothing else, or that you use for energy purpose. But okay, only some specific. If you take municipal waste and you are trying to make compost out of it, the quality will be so poor that finally, unless you have a separate collection at the beginning, just collecting only the compostable fraction of the municipal waste, you will never have a good quality for compost.
Okay, thank you, Eric. I will give the word for Fabriciano, please.
Thank you, Gustavo. Hi, Eric. Thank you for your clear presentation. And I have 2 points, just 2 questions. One of them, I just clarify a point that you told Bussato in his question. You told that in some case we have to know the destination of waste to establish the composition or classification, something like that, or not?
Yes, because just an example, you have a waste and you will use in the cement industry or in another recycling industry. In that case, it doesn't matter about the leaching behavior because it will completely change. Take metal scrap, you put it in the steel industry, nobody cares about the leaching behavior. But if you have another waste that you put somewhere else in the environment or for agricultural purpose and so, then you have to know the leaching behavior or landfilling, because then you know, you will see what will be released in the environment, which is not the fact if you have other type of application. So it depends on what you are doing with the waste, which is defining. Take a mixture of plastic with paper, wood, cardboard, which is used as a fuel. That's fine. If it is used as a fuel, it disappears. If you find another application for that, which is staying outside, you could have to make a leaching test just to be sure that nothing will come out. For example, if the phenolic index will increase if you are just storing wood or sawdust outside with the rain. The phenol index will increase because the wood itself is still releasing some material. So you see. But it depends what you are thinking as solution for that. Why should you do a leaching test for an application where it has no impact?
Mm-hmm. Great. I return in that point because in Brazil we have a stabilization that's define the classification of the waste, and sometimes companies doesn't know, they don't know why the destination they will have to the waste. So they have to classify before, and then sometimes they decide some different kind of destination. So you are told us that we have to mix the classification and with destination in the same stabilization. Yeah.
Yes, because as I told you, in Europe, it is the producer which has the obligation to define what is the waste code he's using, which means he should know if it is hazardous or non-hazardous, and he has to know what people will do with this waste, because it is his responsibility. So normally he should know where the waste is going to. And in that case, he should know if the plant that will receive the waste or the landfill, whatever, and so can accept it, and what are the conditions of acceptation. And based on that, he should know what is the test he has to do, independently of it is hazardous or non-hazardous. Because it is the responsibility of the producer not to just throw away its waste. He has to know what will happen with this waste. He is choosing if the waste is going to landfill, to incineration, to recycling, to sorting plant. He is deciding this. And even if he is asking a collector or whatever, or a broker, he has to ask the broker what will happen with this waste. This is responsibility. We have the producer's responsibility, which ends when the waste disappears or when the waste becomes a product. So long it is a waste, so long it is not going to a final destination, it is his responsibility to ensure that the waste will be treated in accordance with the regulations.
Great. And is it present in the European regulation?
Yes. This is what we call the producer's responsibility.
Okay, great.
It's one of the fundamental rules that we have, that he has to know what is happening with his waste, and he has to ensure an appropriate treatment of his waste. Because if he's paying for the treatment of his waste, well, he has to know if it's what the service he's paying, if it is sound or not, and if it is legal or not.
And just one more question. You told us that the list, of course, help us a lot, and we have to use the list first of all. But when we can't use the list, or for example, the mirror enter, and we have to define the composition, of course, to decide the classification, the correct classification of the waste. And in practice, in Europe, do companies does the root of the analysis to decide the composition? You told about the good practices, but is it official in the regulations how to use this good practice? And well, if one company needs to decide the composition, there is some instruction or manual, some things that help us with that.
Yes, there is a manual that is saying how to apply the list of waste, which is, as I said, it is with a star, it is automatically hazardous. If no star, it is not that. If you don't find it in that category, you have to look there and there and there. And normally, you should find always a place where the waste is going in the list. That's something I can provide to you as well. I will send it to Luis, which is the way it is used, way of using the list. But you know, when you have to define if it with a mirror entry, in most cases, we know from the production if it contains hazardous substances or not, if it has to be considered hazardous or not. I gave you an example, some textile that would be used to clean solvents or to clean ink on a printing machine. Automatically, you know it is hazardous and you don't go far. Then you have a mirror entry and you immediately say, this is the mirror entry with a hazardous component, which means in the practice, you don't have to make so often analysis. It's only if you are not sure. If you test, it is flammable. Okay, it is flammable, it is hazardous. Don't go further in analysis, it's enough. You see, that if you see there are 5,000 ppm of bromine, okay, you know it is brominated flame retardant, you know it is classified as hazardous. Point, don't go ahead with that. So you have simplification. The aim is not to make analysis for the pleasure of making analysis. Huh? It's expensive, it takes time, and the producer also wants to have a solution as soon as possible. We have few cases where we have to, and what you have seen as list of analysis where we have all the components, and so this is more for the safety of the workers as well, and to avoid reactions between hazardous liquids.
Thank you very much.
It's a pleasure.
Eric, I will make a short break. We have just to show our schedule. We have time to debate until 11:30 Brazilian time, so more 45 minutes, more or less. And obviously, at the end, the last 10 minutes we will leave to conclusions, and we will make a 5 minutes break. But before that, I just would like to add to the question of Fabriciano one point. I don't know if it's the reality in Europe or not, but I will give you a question. Is there a case when you try, everybody knows how difficult it is to sample, to get a good and representative sample of a waste and something like that, and then you carry out some analytical procedures and come out with a result of a class age 13, something like that, that you have a substance which the limit is 0.05%, and the result give 0.058. Oh, it's hazardous but almost in the edge of the result. let's try to repeat, to reclassify the waste. I would like to know, we have a question. I will open the debate with the second part, giving you the question. You, in our previous talkings, we showed you talk about the procedure to check up the concentration of the substances, the analytical procedure, and so on. But I have doubt about that, because usually the producer will have a conservative position. I don't want if my waste is considered hazardous, it will be more difficult to dispose of. It will cost more. It will limit my possibilities and so on. So how is it a case in Europe?
Yes, it happens, and you have to make a distinction between waste streams that are quite homogeneous. If I take a solvent, it can be quite homogeneous, and that's quite easy to say. If it is 0.58, it is 0.58 or close to that value, and there is no discussion. You can have more heterogeneous material. Think about shredded light fraction from municipal solid waste. It can be everything. And in that case, we work with statistics, which means, okay, today you have 0.58, tomorrow you will 0.47 and something like that. And then we work with statistics saying in a stockpile of 1,000 or 5,000 tons, like you can find the standard, we say we take averages. It's not so much important if you're looking to the caloric value. It can be important for some plants if you look to the standard for the ISO 300. If you are speaking, is it in that class or that class? Am I at 0.5 for the chlorine or just below or just after? It doesn't matter. If you look for the standards for the mercury, because the mercury fluctuates much more and we have lower value, then it is said that we are working with mean value and with 80 percentile value just because of that problematic. But we use it for the standard. We are not using systematically for classifying a waste. You have seen my presentation if it's below or more than 1%. What is happening if I have 0.98? Well, I will say anyway, non-hazardous, but please manage it with all the cautiously as if it was hazardous. I will give you a stupid example I have been facing some years ago. People was proposing me ammonium nitrate, 34.5% water. And you know it is explosive from 35%. Okay, what do you do? And I said, okay, guy, you know, I agree it is not explosive, but I will not take it anyway, because if there is some rain or some moisture in the air, it will explode, so I don't want. That's it. And this is where you need to be a little bit clever also when you are close to a limit. Okay, that's for sure. That's for sure.
There are other questions coming, but we will make a 5 minutes break. So
not a problem.
Okay, and then we will come out with that discussion, centering the discussion at this point. We have in Brazil, as I showed before, we classify the substance as toxic, the hazardous of the waste as toxic, just using a leaching analysis. We don't consider the elemental composition and the concentration of substance. We don't use ECA or something like that. And that's the question we have been discussing. Is it, how difficult would it be? No, this is too complicated. Oh, it's impossible for us. It's very away from our reality. And that's the question. Is it possible to apply, to have a methodology like analytical procedure, like Fabriciano mentioned as well, to carry out the analysis and to come out with the answers? As we know all the exceptions that we have, but come out with the answers for that. It's for after the break, okay? So it's my watch here is 10:52. At 11 sharply we will be back, just to give you a break as well to have some water. Okay?
Okay.
And we will organize here our stuff. Thank you very much. See you at 11.
Okay, perfect. Thank you.
Okay, thanks. we have some good questions coming. Just wait 11. We start to discuss again.
It's very interesting to see the questions. It shows that there are different approaches in the world. That's great. That's fine.
And the same that we globally we share the same challenge dealing with wastes.
I will show you one small thing if you agree. This is the regulation we have for the wastewater treatment sludge. And you see that we are considering some metals, but have a look there. We are also looking how much metal we can add to the ground compared to what it still has. You see?
You can after send us which regulation is this one?
This is the regulation on the use of sludge to the agriculture.
Okay.
Sorry, it's in Portuguese.
Let me talk. A gente está conversando, obviamente, como todos estão participando, sabem que tem a tradução simultânea e aqueles que querem dirigir suas perguntas também em português, podem dirigir em português, que a gente conta com a tradução simultânea. Até o intervalo foi para a gente deixar o nosso tradutor poder respirar um pouco, né? Que ele não tem folga, ele trabalha quando qualquer um está falando. Nós temos mais, então, 25 minutos para o debate. Vou retomar a questão. Eric, as I told you, and we talked before, we have two ways in Brazil we are to choose in this case. Either we keep on the track of the EPA, US EPA model, or we migrate to OCD. I don't know if in English this, how do you say that? OCD and European
OECD,
model.
yes.
Yeah. And then in this case, we have, the question is, as I told you before, how do we analyze a waste here? We do some very brief pH and something other small analysis, and then take a leachate to classify whether it's hazardous or not. And then we have doubts about, no, we will migrate to the class of ECHA, using ECHA reference, for instance, but we have thousands of substances. How we will analyze that? How will be the procedure, lab procedures, extraction, one extraction, two extraction, how we can make it a consistent process and easy, in a easy way to the people to apply and use that without making a big confusion. We can't do that. So yes. You explained me before about your spreadsheets and so on. How do you do some extractions? And if you could talk about that about for us, I would be glad.
The difficulty is, how do you find the components in the waste? I will give another very easy case. You can, in liquid, you can, in some sludge, whatever, use the leaching behavior. That's fine. Now take a window frame, which is made out of PVC. The old PVC will contain lead and cadmium. If you make a leaching test, you will never find it. You have to burn it, and then you can measure the metals. Or you can shred it and use a XRD, and you will immediately see the metal as well. These are the two ways you can do. One, directly by measuring with a XRD the metals that you can have in the pieces of PVC, and the other is you burn, and then after that you measure what you have in the ashes. Both methods are valid. but a leaching test will never give you the right value. This is why you can never find the universal method that works that fits for all. It doesn't work. It will work for some components. It will not work at all for other waste. I'm sorry, that's a difficulty.
Could you please tell us about the extraction procedures when you have an organic substance to search for organic substance?
When you have organic substance, you usually use hexane. Hexane is the easiest way to. But if you have and then you inject in a GCMS. If you have polar molecules, which is more in water, which are much more leachable in water, then you use dichloromethane for extraction. But the dichloromethane is carcinogenic, so we are more cautious when we use it, and we try to use hexane as much as possible. Also, when you make an extraction, as I said before, be aware that the small molecules are the more hazardous. You will never take sawdust with oil. You will never extract the wood. You will only extract the components of the oil. But the wood is not hazardous. If you make an extraction with paint, you will not extract the resins, but the resin is not problematic. It is the small components that are coming in the solvent that are hazardous. You see, this is why when we are making analysis like that, we also look, what is the percentage of components that we identify? We know that we have water, we know that we have minerals, and we are looking how much of the organics we are identifying. Because it doesn't matter what are the heavy molecules, they will never go in contact with you, they will never move to the environment, they will stay where they are. So the hazardous one are the smallest one.
So you mean when you, I will simplify very much,
Yeah.
too much maybe, but when you have, when you want to search for organics, you make an hexane extraction and analyze by gas chromatography.
Yes.
And there you find the substance that can mean any kind of hazardous.
Yes, and then if you use a standard, you cannot find a standard for all the substances. Then what do you use? You use the more hazardous one, or you use the more frequent one. Methanol is a very classic toxic substance. Acrylonitrile is a very volatile and hazardous substance. 75 milligram in the air, in 1 cubic meter of the air, 1 hour, you die. So if you have 50% of it in a solvent, you have 1 tank of 25 ton, you can calculate how many millions of cubic meter of air you can make toxic out of it. You see? Benzene, because it's in the regulation, very easy. Toluene, because it's a very classical molecule that you find in a lot of mixture of solvents. And you see, this is the way you identify the standards you use to quantify. And the other, you make a semi-quantitative, but that's enough. It gives you a good idea of what you can expect as a concentration in the components, in the mixture. You see the way it works? And if you have a specific customer which has a very specific molecules, then you use the standard for the specific molecule as well.
Okay, thank you. I will address the other questions. First one is from Enrique Mendes. Thank you for this great presentation, Mr. Eric. And I totally agree with its responsibility of the producer of the waste to know what will be done with his waste. In Brazil, it's also the producer's responsibility to know and manage it correctly. In our national waste policy, Article 27, it's pretty clear that the producer will respond legally, and if any damage is done by a mismanagement of a third-party waste manager hired by the producer. Therefore, it's very reasonable to link the type of classification tests based on the technology of the final destination of waste. The producer must know what will be done with the waste that his company has generated. This minimum management and his legal, this is minimum management and his legal responsibility, its legal responsibility. There's another question in this point. I will try to figure it out. From Eduardo Shiramata. Dear Eric, thank you for excellent presentation. So based on answers so far, the same waste could be classified at the same time, hazardous and non-hazardous, based on different application or destination, if more than one is ongoing. So he say if you have a waste, and depending on the destination, he can use two parallel destination, and in one case can it be classified as hazardous and another one non-hazardous? This is the question.
No, I'm sorry for that. This is a misunderstanding. It will always be or hazardous or non-hazardous. But the test you will have to do to define what destination you choose is changing. But hazardous is always hazardous and non-hazardous always non-hazardous. That doesn't change whatever the destination. Be aware also one of the discussion we had was the H14, which is ecotoxicity. How does it work? Very easily. We take a certain quantity of the waste, we put it into water, we have Daphne, and we look within 8 hours, 1 day, 2 days, how many Daphnes are working. Or we use algae, which are bioluminescent, and we calculate the reduction of bioluminescence that we have from the algae to give an idea if it is ecotoxic or not. This is obviously what you will use if there is risk that the waste is contact with water. But if you use a waste for another purpose where there is no contact with water at all, why would you use that test? Just for the classification. But if you have another parameter that say it is hazardous, that's enough. Don't make that test.
Okay, thank you.
But hazardous will always be hazardous, whatever. But within hazardous, you can choose different solutions based on the other properties. And within non-hazardous, you can choose different solutions based on the properties as well.
Okay. Another question from Eduardo. Dear Eric, one more question. You mentioned the discussion about waste versus byproducts and end of waste criteria. Could you go back to these criteria? And is the producer also responsible for defining, based on the criteria, if a material is not a waste, being a byproduct or a secondary material through the end of waste criteria? If not, what's the process for this definition? Are materials defined as byproducts and or secondary materials still classified as hazardous or non-hazardous wastes?
It doesn't matter hazardous and non-hazardous. You can have a byproduct which is hazardous, and you can have a byproduct which is not hazardous. So it is the way how it is produced, unintentionally, but coming from a production process. And you to be sure that you will use it in a process. That's important. If I have steel slag from a blast furnace and I put it in landfill, it is a waste. If I am using it as a raw material for other application, it is not a waste. If the authority agrees on, and if you look there on the bottom, it is seen must be REACH registered. It means each product that you put on the market in Europe has to be registered under REACH, with some exceptions which are natural material like wood, for example. But it means if you put something on the market, fly ashes from a coal-fired power plant, this is a material which does not exist in nature, it is produced by human activity, then it has to be REACH registered, which means that you have to identify the components, the reactions, the heavy metals it can contain and things like that before you can consider it is a byproduct. And you have to ask your authority if they agree it is a byproduct or not. Some authority do not, but in most cases the authority are asking please inform us if you want to have a byproduct status for that material. If the authority disagrees, then it is a waste. Only if authority agrees, then it can be a waste, byproduct, but it has always to be REACH registered, which is not the case for waste. Wastes are not automatically registered.
Okay, thank you, Eric.
I don't know if it is clear enough. It's sometimes ambiguous, but as I told, you can have a tank, and in tank, depending if you put it in landfill or you use it as waste, or if it is going to a production process, it is waste or non-waste in the same tank.
There's another question about that. It was made before your answer, but I can add it in case to help in this question. Is how from Priscila Ferreira. How is the classification of byproducts? Do companies in Europe have access to hazardous properties database? There are two different, but yet about byproducts. In this case,
yes,
who defines the byproduct? Sorry, excuse me.
You can have access to REACH to find the data, but you have to pay if you want to register your material under REACH. Imagine one company did all the studies, paid 500,000 euro to make all the studies, and then you are coming, oh, I just take those data and that's fine. No, it is not the way it works. So you have to pay as well to be able to use the data which are still existing. I had the case 2 or 3 years ago, importing fly ashes from coal-fired power plant from Japan, because in Europe we are closing all coal-fired power plants and we were looking for fly ashes. Well, we had all the Japanese producer or the importer in Europe had to register the fly ashes under REACH and had to pay for the registration and using the data which were still existing in REACH. That's the way it works. But you cannot put a material, you cannot put a product on the market in Europe without registration under REACH.
So
only waste is an exemption.
This is a good example. So fly ash can be is considered a secondary material or byproduct?
Yes.
Okay. So it's not treated as a waste. Only if
I can give you another example. Glass blast furnace slags. The UK authorities said, well, in our country, for the use in the cement industry, I'm sorry speaking about cement industry because I'm afraid of that, it is a byproduct. But if you export it after the UK, it depends on the status that the authority gives in the country of destination. That's the way it works. So if you want to move it from one country to another country, you have to be sure that both authorities agree it is a byproduct. If not, you have to apply all the rules for waste.
Okay. Tasso sent another question, Tasso Cipriano. I don't know if he wants to talk about that or that we read it. Tasso is there if you want to speak. He's without microphone. So I will read for you. Dear Eric, as far as I'm concerned, in the case of controversy between, for example, waste producer, facility operator, or waste producer and authority, as to whether a waste stream is hazardous or not, and its hazardousness has been assessed by a test, the test shall prevail. Is that correct?
Yes. Yes, it is correct. If a test says it is hazardous, it's hazardous. For so far, the waste which is delivered has the same quality, because the qualities can fluctuate. And I didn't spoke about it, but there is one point as well. Some people with bad intention will try to dilute hazardous waste in non-hazardous waste. So that if you are below a certain level, you will say it's not hazardous. And this is something which is not accepted in the EU. It's example, you have a waste with PCB and a waste without PCB. You mix both and then you are below the threshold of 50 ppm and you will say it's not PCB. This is not acceptable. Usually when you mix hazardous with non-hazardous, you have to consider that when it is just mixing, you have to consider that the total mixture is hazardous, even if you are then below, just to avoid declassification by dilution, which is not accepted.
Good point. Very good point. Well, we still have a time for a last question. If
So
someone...
I'm available. For my side, it's fine.
Yeah, then we can make a closing. Not ceremony, but just a closing. Is there another question from Tasso? Is testing a reality for assessing the hazardous properties of wastes that are heterogeneous rather than homogeneous? Are there technical standards for sampling?
There are standards for sampling for non-hazardous, and you know them. This is the ISO TC 300, where you can find a lot of details in it, and it depends of the fluctuation of the concentration of each particles. It depends of the dimension of each particles, but sometimes you have to make compromises, because if you have huge fluctuations, take an example. I have polyethylene and I have some pieces of PVC with 50% of chloride. So this is a very huge variation. And I have pieces that are 20 centimeters wide. If you make the calculation, it could be that the sample you have to take is bigger than the truck. So somewhere you have to find a practical compromise as well. And this is why for that kind of case, we work with averages, with mean, with the 80 percentile and things like that.
I would add, in terms of, is it possible to give a number, a percentage, how many of the waste, forgot the word, of different types of waste are, how many of them need to carry out an analytical procedure, and how many are classified directly by the list? 70%, 50-50?
Oh, I would say 95% are automatically classified, and only a few percentage you need to make analysis between hazardous and non-hazardous. But after that, you've seen other regulations. If you want to use for agricultural purpose, you make other analysis. If you want to put it in landfill, other analysis. If you want to recycle it as aggregate analysis, if you want to use it for glass cullet, other analysis. So it's case by case. Huh?
Okay.
That's just a single example. If I want to recycle my PET bottle, today they say, well, you can have 2%, which is not the PET. But I have the top, which is high-density polyethylene. I have the etiquette, which is paper. Is it 2% or less? Because I can still have some droplets of water in it. This is the kind of test you have to do if you want to speak about recycling of PET, just for that purpose. So each kind of process has its own requisite and request.
Okay.
Also, you see, I spoke about the tire. Tire with zinc oxide should be classified as ecotoxic. It is not, because the tire you can put in the water. If you take the tire dust on the road, then the dust can be much more hazardous than the tire itself.
Yeah, sure. Well, I will speak. I will start the finishing, and I will speak a bit in Portuguese. Eu gostaria só de lembrar. Merci. First of all, thanks a lot, Eric, for. I will speak in Portuguese. I forgot.
No, not problem.
Muito obrigado pelo seu tempo, por dedicar o seu tempo, suas horas para nós, tanto na preparação do evento, né, quanto hoje. É muito importante para a gente entender um pouco da realidade, do contexto de quem trabalha há tanto tempo, né, com resíduos na Europa, né? Eu ia comentar antes, você começou em 85, portanto, antes da publicação da primeira norma de classificação de resíduos no Brasil, né? E eu gostaria de dizer também, porque o nosso trabalho na comissão da Abnt, essa questão, por exemplo, das análises estatísticas das amostras, já fazem parte dos anexos dessa publicação, das últimas duas normas que tratam aí do aproveitamento energético de resíduos. Então, a gente está tentando trazer essas realidades para o nosso país aqui, para que a gente possa estar aí no estado da arte do gerenciamento de resíduos. Eu acho que o evento, obviamente, não esgota o assunto, e certamente no mundo, né, o assunto nunca se esgota, né, o assunto de resíduos, e a gente tem uma dinâmica muito grande, além de um universo gigantesco de pontos, né, de temas, de variedades, né, é um assunto que está dinâmico, né, com a velocidade da tecnologia e com as inovações, né? Então, a gente tem que sempre ter o cuidado de não querer abraçar todo esse universo, porque ele não é possível de a gente abraçar, né? Mas a gente pode ter regras claras, pode tratar exceções, né? Pode ter uma forma bastante objetiva, né, de tratar a questão dos resíduos, e é isso que a gente espera. Então, eu agradeço mais uma vez, Eric, e abro para você, se quiser fazer suas últimas considerações.
Well, I've seen last questions about hazardous fly ashes from hazardous waste incineration. That's very easy, you know, when you know the process. Obviously, you will have the metals on the form of oxide and chloride, which are more volatile. So you will find the metals in the fly ashes of hazardous waste incinerator. So automatically, you will classify it as hazardous. That's a classical example. You were speaking before the break about possible leaching test. There are two tests to consider. You put the granulates in the water and you see what is happening. Or you mill the granulates and you see what is happening. These are two different tests, because in one side, you are looking to a short-term leaching behavior, and the other one is a longer-term leaching behavior. Both are existing. I can have looked to the standard for that if you want. But we have to use both depending on the application again. And please, Luis, you can give my address, email address, whatever, if others want to have other questions. It's not a problem. I will try to answer to them.
No, it's very kind of you. You help us a lot. Congratulations again. Thank you very much for your presentation.
Thank you.
Vanessa, you can make the final remarks to finish. I don't know if
Ok.
Vanessa...
A Abnt agradece a todos pela participação e até uma próxima.
Thank you, Eric. Bye. Thank you very
Thanks
much.
to all of you. And have a nice day.
Much,
Bye-bye.
Eric.
Thank you.
Parabéns, Busato. Parabéns a todos.
Eric, next time we need to take a beer, né? To celebrate it. Acho que ele já foi embora. Tchau, obrigado, Nelson.
Tchau, tchau, parabéns. Excelente.
Tchau, tchau, parabéns.